Hey everybody, thank you so much for joining me today for looking at infiltration and the design process. So when we were starting out, we were asked to identify a state standard. I went with the PA Environmental and Ecology Standard 4.8.4, how human activities can influence, change, and affect the natural environment. And then moving on to the engineering design process, the first process of ask to identify and research and need. And our question was, how does soil and land cover impact infiltration and runoff? As I explored the runoff simulator online, some of the observations that I made were soil with higher infiltration leads to less runoff. Increased impervious surfaces will increase the runoff and decrease infiltration rates. Land cover that has lots of plants has higher levels of transpiration, and soil infiltration does not impact evapotranspiration rates. And when I wanted to kind of explore a little bit deeper was the increase in impervious surfaces leading to an increase in runoff and a decrease in infiltration. I wanted to check that out a little bit deeper with the experiment. To start off, I needed to identify my soil hydrologic group that would be in my backyard, the soil I was planning on using. I went to the USDA's Web Soil Survey and found out my hydrologic group and drainage class was moderately well drained, and thus I could update that information on the runoff simulator. And I did 3 different land covers: high density with lots of impervious surfaces, low density with medium, and then barren land that had no impervious surfaces. Well, I guess like concrete, so on and so forth. Took those numbers and the infiltration and runoff rates. I put it into a table and calculated the percent of runoff and infiltration because I knew that I wouldn't be able to get as precise measurements as 5 centimeters. So I wanted to be able to translate the information as I did my experiment. I moved on to the imagine stage where I kind of looked around my house at the different tools and the different materials that I had on hand, and I developed this prototype. So I had my 3 different land covers: low developed, high developed, and barren land. To be able to measure infiltration, I poked holes on the bottom. I got a catch basin for infiltration and runoff. I got a big measuring cup so I could replicate my storm event more accurately, and my cute little storm cloud elephant. Then I tested my prototype in the create phase, and this is a visual image of what I got. And then I decided to also do my table and fill that out a little bit more, added in my measurements and my overall observations where there was less runoff with plants, more infiltration with plants, and more impervious surfaces means more runoff rates or higher runoff rates. Then during the improve, I looked at modifying and retesting my solution, and I came up with a whole slew of things that I can do to improve my setup, which would be more precise measurements of water, and dialing in the barren land, making more even infiltration holes, and mimicking rain better, and using plants with more established roots. Then other questions I thought I could ask were how I could make a bigger one with longer rooted plants to see if root depth changes things, and to do a percolation test in my backyard to verify my soil group. So here are the STEM practices that lined up. Sorry, the slide didn't update, so just ignore modifying and retesting solutions. But those were the different practices that I hit, and by calculating percentages, I thought that I was able to hit more of those mathematical practices. And of course, using this technology online, checked a lot more boxes with that as well. So thank you all so much for joining me. I hope you had as much fun as I did, and I can't wait to see your videos here in a few minutes. Thanks.